so much for giving your time on a weekend. I understand many of you would prefer not to do that, but I'm assuming all the people who have joined here are pretty focused and serious about your career. So I welcome you all, and thankful to all our viewers for the overwhelming response we have got with reference to the number of views on this. It's really heartening to know that our efforts are bringing to some fruition. All right, so let's begin. Let us conclude the first week's program today by continuing our discussion with reference to data pre-processing. And we have, for people who are joining just today, we are taking the method of, we are talking about a project that the interviewees have been, asked, and it is continuing. So whatever they have worked on the project, we are continuing the questioning with reference to that project. So here is my first question to Sharath. So Sharath, with reference to your project, can you explain about binning and how did you use binning in your project? And the third part of the question is, why do you need to do binning in the first place?
Thank you, Nitin, and good evening, everyone. So jumping into the character and trying to answer the question here. So the question was, what is about the binning thing and why we need to use that and how it actually helps in dealing with our data. Well, the concept of binning basically is used when we have very large data for interpretation. For example, fuel efficiency is something that I was working on in my project. So that was my target variable, and it's in continuous in nature. Now, if assume that the range of these values is very, very large, the fuel efficiency of a vehicle could be somewhere around 5 kilometers per liter fuel. So somewhere around, let's assume that we have a specialist car, very unique car, very special car, which gives us, let's say, 50 kilometers per liter. Of course, it could be a fantasy thing, but let's assume that this is the range of the data that we have. Now, when I try to work on this particular data set, I would have to try and predict this results. And because of the variation that I have, I may not be able to get the appropriate result because of that too much of variation that I have. So what we try to do is try to bin this particular values so that it is also easy for us to apply classification methods and also try and interpret the results in much more homogeneous way. So what we did is we took this fuel efficiency range and we split that. For example, 5 kilometers per liter vehicle till 15 kilometers per liter. This is section 1. We called it as bin 1. You can also give fancy names, but this is one bin. Then from there onwards, upwards, 15 kilometers per liter, upward onwards, till 30 kilometers per liter, this was bin 2. And anything above that was a supercar. It was literally giving us good results. So this way we were able to try and split the range into 3 different categories or bins. Now what happens is when I try to analyze the data with respect to discrete finite set of values, I will be able to come up with much more statistical inferences. It becomes easy for us to understand the data. So that is one of the reasons why we also do binning, especially when we have large range of values. And of course, your business requirements might call in for. Now to do that, we used cut function, very simple function. And we decided to give the customized bin sizes. It's not fixed size. So as you can imagine, I said 5 to 15, the width is 10 units, 15 to 30, that was the width is 15 units, and anything upwards from 30 to 50 was 20 units. So this was a different bin sizes that we were able to give and split our data into buckets.
Thank you. Thank you so much, Sharath. Barney, your take on this question and Any
Yeah,
other approach?
absolutely. So the project which I worked upon was related to loan default prediction model in the space of bank. And here interpretation is extremely important. When you reject a loan, for instance, of a customer, and if the customer asks for the reason on why you have rejected the loan, you as a bank should be in a position to give a reason on why you have rejected the loan. Given this context, we have proceeded further with two algorithms. One was decision tree and another was logistic regression. Both of these have a lot of interpretation capabilities. Decision tree expects the input variables which we are supplying to be in categorical format. And we had numerical columns such as income, age, etc. When you supply these as is to decision tree would automatically convert them, that is continuous or numeric data, into categorical data. It would automatically do that using its own logic. Now, if you don't want some other logic, and if you want your own business logic to be applied in terms of converting continuous into discrete, then you create buckets or bins, and you say that salaries less than $5,000 would be part of category 1. Salaries in the range of 5,000 to 10,000 would be category 2. Salaries in excess of 10,000 would be category 3. Probably this makes more sense for your business. So based on that, you create such buckets or bins rather than leave it for your algorithm to determine automatically different bins of its choice. So this is a scenario where we have resorted to binning. Thank you.
Thank you, Bernie. Thank you. So to sum it up, ultimately, the necessity for binning data is for convenience, predominantly convenience. That convenience could be because you are able to use simpler algorithms. That convenience could be you are able to have different groups of data to understand the various ranges of values. It could be various things. So the context of your answer should be in context with why you have chosen the size of the bin and how it is going to be convenient for your model or the algorithm that you have chosen. So that is effectively the summation of the reason for binning. Okay, thank you, both of you. So the next question is, again, like I said, we are going to be in the space of data pre-processing. So next question is with reference to encoding. All right, another interesting thing. And data scientists are always in argument, no, this is better, that is better. So when did you use encoding, Sharath, and what are all the types of encoding techniques did you try before you decided, okay, this is the best?
Okay, Nitin, to answer that question, I have to first explain what exactly the encoding point is, right? So from a business perspective also, if I have non-numeric data points in my data set, for example, engine type, because if I have to calculate or predict or estimate the fuel efficiency of a vehicle, the engine is going to play a very crucial role. Now, this is a non-numeric data and I could not skip this. It has to be there in the data for analysis and prediction models. But if I have this non-numeric data, I cannot come up with a mathematical equation, a machine learning model, right? A regression model. So from this perspective, I had to convert the non-numeric data and represent that non-numeric data in a numeric form. This is where we try to encode the original data and create dummy variables. And here, there are different types of doing the encoding, of course, but the logic says that if you have a data which is of equal importance for every category in that particular field, for example, I should give equal importance for a petrol vehicle compared to a diesel vehicle, or for that matter, for an hybrid vehicle or an electronic vehicle. In the equation, the coefficient should identify the importance of this type of engine on the fuel efficiency, but I should not give some numeric advantage to that category. So to ensure that we give equal importance to all the categories, we generally try one hot encoding technique, which basically gives multiple columns, and we basically have the columns extended based on the number of categories that we have. Those many columns extended. Of course, this is one of the drawback, which may yield into a dimensionality curse, especially if I have too many columns. But in our case, in my specific case, the project that I was working on, I had only 5 categories. So it was not a big problem for me to convert the data into one hot encoded variables. Once they are converted, I was able to use those columns into my numeric equation, right? Regression equation. And we can also try and apply different encoding techniques, but predominantly we either use label encoding techniques or one hot encoding technique. So in my case, I was using one hot encoded technique.
Thank you, Sharad. Thank you so much. So, Barney, do you have anything to add, your insights or any experiences you had with problems basically with this encoding?
Yeah, absolutely, Nitin. So within the project that I've worked upon, which is the loan default prediction model, there was a column called as education. Education has diploma, graduation, post-graduation, so on and so forth. Given this, if you are going to supply this data to an algorithm such as decision tree, all good. You need not do any changes to this specific column. However, I've told you that we have also applied logistic regression. When you apply logistic regression kind of model or any of the regression techniques, the algorithms expect your data to be in numeric format. So you cannot say education, diploma, graduation, post-graduation, and supply the data to your model, logistic regression model. You need to instead convert this column called education into numeric format. And in order to convert that into numeric format, we resorted to dummy variable creation. And as part of dummy variable creation, if you have diploma, graduation, and post-graduation, there'll be 3 different columns which will be created. And there'll be one against a row which says, say the first row says diploma. So against diploma column, you'll have a 1, against graduation 0, against post-graduation 0, right? That's how you do one hot encoding. The reason being, your logistic regression expects the data to be in numeric format. So in the previous example, we had a column called as income. We converted that into categorical data because decision tree expects the inputs to be in categorical format. But logistic regression expects the data to be in numeric format. Hence, the categorical column, which was education, was converted into numeric format using dummy variable creation. Yeah, thank you.
Thank you, Bernie. Thank you for that answer there. So, to sum it up, the choice of the encoding method, unfortunately, is it changes with the kind of data and changes with the kind of algorithm that is demanding it. All right. So, label encoding and one-hot encoding are the most popular ones. So, you would choose that depending on the algorithm, and different algorithms require, different types of encoding. So that is something you will have to try out and then figure out what suits you the best. So that is the answer to the part, why do you choose among the various encoding techniques? So that was something I wanted to just step in. All right. So moving along and continuing the things in data pre-processing, because like we say, data pre-processing, EDA, etc., is the major chunk of it. So transformation, all right. Now that's again a very gray area amongst data scientists, and definitely a cause for arguments. And the temperatures run high. This is better, that is better, etc. So I would want Barney this time to speak first about what do you feel is a good transformation technique vis-a-vis the project that you have done, and the reasons why you chose that particular transformation technique.
Sure, absolutely. So, basically, there are multiple, times when you want to transform your data. One such reason would be if your data follows a non-linear pattern. What do I mean by that? If you plot the data and if you look at the distribution of the data, if the data falls along a straight line, you say that that's a linear pattern. However, when we have plotted income in the loan default prediction model, we were seeing a curve which was expanding or which was growing rapidly until certain time it was increasing in a linear fashion, and then we have seen a sudden increase. And you ask any economist and they would say that income as a variable will follow the upward curve kind of a format, kind of a pattern, which is called as exponential pattern. When you have exponential pattern, then if you use that income variable as is in your prediction model, it will not give you good results. It will not be able to capture the patterns well. So what are you expected to do then? We are expected to perform a transformation which captures that pattern in a nice manner. And one such transformation which people employ when your variable follows exponential distribution is log transformation. The moment you apply log transformation, the exponential patterns in the variable would be captured properly. So the point that I'm trying to drive is you have to do your exploratory data analysis properly. You need to look at your probability distributions and understand whether the variables are following linear pattern or exponential pattern or some kind of polynomial pattern, etc. And based on that, you will have to include the appropriate variables in your model so as to get good accuracy. So instead of using income in your model, you need to use log of income. Why log of income? Because that's following exponential distribution. And in this case, we were lucky that we came to know that it was exponential distribution. In most cases, the distributions would be very dicey. While just looking at the variable, you might not be able to figure out what kind of distribution it follows. And that is when we need to experiment. We can do a log transformation or exponential transformation or square root transformation or cube root, so on and so forth. And the question which often we encounter is, how many such experiments do I perform? For how long do I perform? It is directly proportional to the amount of time that you have on your project. Certain clients might say, we want to complete this project in 1 week. So you might not have the luxury to experiment a lot of transformations. Certain customers might say, I'll give you 3 months time. Okay, if 3 months time is provided, then you need to keep experimenting, more experiments, right? The more you experiment, better would be the results at the end of the day. This is one scenario. Another scenario is when your data are non-normal. When your data are non-normal, you cannot apply certain statistical techniques, because when people have come up with those algorithms and techniques, they build those algorithms assuming that the underlying data are normally distributed. So the moment you know that data are non-normal, you cannot apply these kind of techniques. If you cannot apply the techniques, you cannot glean meaningful information from your data. So it warrants an additional step of doing transformation. And through transformation, if your variable becomes normal, wonderful. You can apply all those techniques which assume that your data should be normally distributed. Right? And in a few other scenarios, we use transformation, but predominantly on our project, these are the scenarios where we have used that. Yeah, thank you.
Thank you, Barney. Thank you for that detailed answer. I'm sure that was quite helpful for the audiences here. So Sharath, anything you'd like to add? Anything with your experience you'd like to add further?
Yes, just to add to Mr. Burney's answer, um, I would probably take a route of the statistical way to explain things here. The thumb rules in statistics that we use, the logic that we are using for EDA and trying to extract information, um, there is some standard thumb rule, right? So the representation of the standard thumb rule is done using a standard variable. It's a pseudo or theoretical variable, theoretical data, which is represented by Z in statistical terminologies. We call it as standard normal random variable. Now, the world as is to be assumed that it is a normal place. So that means the data that we are going to consume and start working on is also assumed to be normal. When I say normal, that means we don't have exceptional cases in the data. Now, if I have exceptions, then the analysis takes a different route. If my data is normal, then I can directly apply a lot of statistical calculations, theorems, which are already defined, like Mr. Barney was saying. So it becomes easy for me to analyze the data. So if my data was not normal, in our case, in my case, the fuel efficiency, which is the target variable itself, was not normal because we had exceptions. Like we had a couple of cars which were giving us very, very high efficiency, like 31.5, something on those lines. Exact number I couldn't recollect, but it is definitely very high. So these were abnormal. So when I wanted to work on this particular data, I had to ensure that it is converted into something called as normal distribution. So what we do basically is we compare the distribution within the data with this standard variable. One of the key characteristics with the standard variable is that it is identically distributed. That means the difference between the points, data points, is evenly spread. If your data also has this kind of a spread, then you can safely assume that it is normally distributed. So this was a comparison that we do. This is what we do. And if we identify that this comparison is not similar, then obviously, like Mr. Burney said, the distribution will show, the image will show a non-linear shape in the two-dimensional diagram. We generally call it as normal QQ plot, as we all know. And in order to transform the distribution of the data, rather than applying manual techniques, because there is no end to experimentation here, and we don't have any standards to say that if data seems to be in this form, then it can be declared as, or it has to be declared as normal. It's more of a subjective decision that we take. So to ensure that we have some kind of a consistency, we try to use the standard libraries, which are basically doing all these experimentations in the backend using some mathematical formulas, and gives us the best transformed data. So this is one of the libraries that I experimented with, was Cox transformation. And it automatically takes care of all those iterations in the backend to check what magnitude conversion to the original data will ensure that it becomes normal. So this is basically how transformations is becoming very essential, and how we treat this as this non-normal data also becomes very essential for our project work.
Thank you, Sharad. So quickly stepping out of character, I'm supposed to be the interviewer here. So in my experience of training people and telling them about how EDA and data pre-processing will take up enormous amount of your time towards all these activities. And I also used to tell them that you will actually feel like plucking your hair. But during the training, everybody focuses on the algorithms, which is also good, but kind of at the cost of these EDA and data pre-processing techniques. So I've had many participants come back to me and said, "Sir, you are right. Absolutely correct. It's been 20 days and I'm still, working on the data, still doing this. And so much of pressure is only, I've not even decided whether I want to go for what kind of algorithm, let alone start working. I'm still on the data, understanding the data phase itself." So that is the reason why the three of us with our experience are trying to push you people to impress upon your interviewers who are going to interview you to tell them that this is the problem. Because if you try to focus, this algorithm I used, this many techniques I did, that, this, it's more, it kind of tells you that you are kind of bookish. You really don't have the, hardcore experience with reference to projects. Because if you've had, if somebody will ask you, what was the problems you faced? This algorithm did not work, so we tried a different algorithm. Straight away, the interviewer will know this is something not, I don't want to use the word fake, but yeah, this is something fake. All right. So that is the reason why we are focusing here. All right. So I think we've run out of time, but I'll just, give Barney one small question to quickly wrap up today's session. The question is with reference to scaling, Barney, Mr. Barney. Could you explain to me, rather than what scaling you have done in your project, for want of time, I'll restrict it to why scaling is necessary, generically speaking.
Okay. So if you take an example of the kind of projects which Sharath was handling with respect to automotive, if you have an output variable called mileage, right? If you want to predict mileage of a vehicle, and say you're measuring the weight of a vehicle in kgs, you'll have some number, say 100 kgs. If you put that in the equation, prediction equation, the specific value, then you'll get some mileage. However, if I were to change the units of weight and change that to, for example, pounds, so 100 kgs will become 220 pounds. In the same equation, if I use 220 and then do the calculation, the mileage will skyrocket. For the same vehicle, just because I'm measuring the weight in pounds, the mileage should not be high. Just because I'm measuring in kgs, mileage should not be less, right? So mileage should not vary based on the units that I'm using. If the units are in kgs, it'll be a smaller number. If the units are in pounds, it will be a bigger number. Your model should not be impacted by that, right? So that's one reason why we use scaling. Another reason is whenever you have algorithms which use distance, for example, clustering algorithms or your KNN algorithm, your SVM for that case, which also calculates the distance. Whenever you're using algorithms which calculates the distance, if you want to calculate the distance between two rows, two records, and say you have one column called age will be usually in 2 digits. And say you have another column called income, that will be in 4 or 5 digits, depending on the currency that you're using, right? So here, the column called age will have least influence on the distance because it will be of smaller scale, 2 units, 2 digits. Whereas when you look at income, since it'll be of 4 or 5 digits, that will have very huge influence on the distance. Your model should not work in that way. All of your variables should have equal influence on distance. So that is also another reason why we need to scale the data. So one golden rule is that the moment you look at the data, if you have different columns of different scales, meaning one column has 32, 33, 34 in that way numbers. Another column has 100,000, 200,000, 300,000 in that way, bigger numbers. Then you just need to perform scaling.
Thank you.
Thank you.
Thank you so much, Barney. It was quite interesting, both Sharath and Barney. And unfortunately, we have scheduled it to 30-minute capsules of these programs. So we'll stick to that. And today is another phase completion. We've completed 5 days of this event that we are conducting, and you will be receiving a lot of content, the mind map, the PDF document, etc., and the websites. It'll be informed to you. All right, so that's one good thing. So I request all of you to keep continuing to support. We will continue on Monday with new topics. And in the interim, please do spread the word, tell your friends about it, tell everybody about it, subscribe, press the bell icon, and also share.